Good afternoon, everyone. And thank you all so much for being here. We're honored to be here presenting today on our war game competition AI. And without further ado, let's jump right into it. So we thought it'd be best to start with a quick round of introductions, who we are and why we're interested in war games. So I'm Vikram. It's wonderful to meet you all. I am a master's candidate in the Security Studies program at Georgetown University. I'm also a recent graduate of the undergraduate program at Georgetown, where I studied science, technology, and international affairs. Um, my main interest is in biosecurity issues, so that includes emerging biotechnology, bioethics, pandemic preparedness, environmental security, really anything with a biology and security component. And I'm a big fan of war games and games in general. I've been playing them for a very long time, and it's wonderful to be here with you all.
Great. I'm Andrew Olson. I'm here representing the Masters in Foreign Service side of the Wall School. I'm a second-year student before coming to Georgetown. I was a research biologist. I did work on genetics of social trust and some emerging bioethics of gene editing technologies. Going forward, be hoping to do more of the same, science and tech policy and emerging biotech, and hopefully continue to do wargaming.
Hello, I'm Sasha Kappas Barkhouse. I'm also in the Security Studies MA at Georgetown. Prior to this, I was an open source intelligence analyst embedded in a tech company where I focused on geopolitical and protective intelligence issues, not cyber. So coming into this program, I was really excited to learn about wargaming and got together with this team to see what we could do.
Great. So as you just heard, all three of us are very into war games, and also all three of us have a shared interest and background in the science and technological. So we have professional backgrounds in biology, intelligence analysis, and S&T policy. So how did we get into this? Well, all of us had this shared prior interest in wargaming, but all of us were, prior to this previous semester, sort of novice wargamers. But at Georgetown University, we took Professor Sebastian Bay's Basics of Wargaming course in fall 2021. And the purpose of the course is really to teach students about design mechanics and also give us the hands-on opportunity to really design our own war game. So this really exciting chance to build a really high-quality prototype, which you can see pictured on the right, over the course of a semester. So the question was, we come into class, we're put into this excellent team with three tech-focused people, and now we have the challenge of coming up with a topic for the war game. What do we want to make? So our immediate idea was, well, we have this shared interest in science and technology, so this is an area of that needs more focus. We'd all, in our professional experiences, come across maybe a little bit of confusion in the policymaking community about science and technology, so this seems like a really great area to make a game. And really, the story of us picking our topic was a story about narrowing the scope. So our initial idea, when we were a little bit big for our britches and our eyes got a little bit wide at all the possibilities, was to do a World War Z game. And the idea was, we're living through COVID. All of us have a bit of bio and science background. Let's do a sort of zombie pandemic response game, which is supposed to be, players have the opportunity to do research on the virus and try and respond to the problems. Sebastian quickly let us know that might be a little bit more than our capabilities at the moment. And so we continued to workshop ideas. So the next we thought, well, why don't we ask around a couple of different organizations and see where they really think there's a need? So we had conversations with the Center for Security and Emerging Technology, CSET, which is a sort of think tank associated with Georgetown that's been extremely helpful to us throughout the process, and a couple of other organizations, and really ask them, so we're interested in doing this game, we're interested in something science policy, where is there a need? And the thing that came up pretty much over and over again was that there's a lot of confusion about how innovation works. How do governments use their resources effectively and investments effectively in order to actually, develop the technology that they need? And in those same conversations, we came across this really fascinating input-based model of innovation. So what do I mean by that? The basic idea is that talent, infrastructure, data, and money are the four inputs that are necessary, particularly for AI innovation, but really innovation in general, in order to successfully develop new technologies. We thought, great, we have this input-based model. it seems like the kind of thing that we could really turn into an effective mechanic for an educational war game, which was our goal. So great. Technology and innovation, we're addressing a need, and we're moving forward with that. So then the next question is, well, what sort of technology and what sort of innovation? And we immediately thought maybe we should do some biology sort of stuff, but then we sort of landed on artificial intelligence. So why artificial intelligence? AI is critically important to the military, and don't take my word for it. Take the U.S. DoD and Chinese Ministry of National Defense for that. They've both established the AI as a major priority. AI technologies can impact warfare in multiple domains, and there's a ton of flexible uses for it. And many AI capabilities are dual use in nature. So there's a really critical role of the private sector here. So here we fell into another trap, which was we got a little bit excited again and decided, well, let's make a game about AI and innovation. And what we're going to try and do is have all these different countries across the world who are involved in the AI race be players and potential roles for our game. And here again, Sebastian had to say, well, pump the brakes. You know, I see that you're interested in all these technologies in biology, and we were including sort of biotechnology that's AI associated. We're including cyber technology, and we had a bunch of like 7 different countries. And he was like, whoa, 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 this is too much. And so we had to narrow our scope down back again to competition between the US and China. And this actually really worked really well for us, because both the US and China obviously want to be global technological leaders in artificial intelligence. And both countries have stated a desire to acquire new technologies quicker than their adversaries. So we're like, well, here's a really nice victory condition for us to have. Who can get the technology quicker? And the question of our game really became, how can each country really innovate faster? How can each country best accomplish their goals? And that led us to our learning objectives, which were, first and most importantly, teaching players the strengths and weaknesses of the systems of innovation in each country, teaching them about the input-based model that we mentioned, and then exploring the relationships between those countries and their private sectors, which we'll talk a little bit about later. We also wanted to demonstrate how really, technology builds on itself. Developing specific AI capabilities early on opens up the path to accessing critical and powerful technologies later. And so the solution we came to sort of turn that into a mechanic was a technology tree, which again we'll talk about later, and we'll show you the game board. And then finally, to introduce players to the most plausible near future AI technologies based on our conversations and our research. So I'll hit you all with the scenario real quick. It's 2021. And the competition between the US and China and AI is on the rise. So we ultimately decided to narrow down the scope even further from US government, China government, to US Department of Defense and Chinese National Defense Ministry. The reason for that is because we thought, the government has so many levers that they can pull on, and we really wanted to reduce the players, the scope of what the player could control over the course of the game in a way that made sense and allowed them to innovate. The objective of both countries is really to acquire a first mover advantage in new various AI applications, which effectively just means get to the technology first, and in particular, get AI technologies that are applicable to the military. I also really quickly want to point out to the right that image. Andrew did a fantastic job of developing and using an AI to actually spit out some really, really cool looking art for us. So please enjoy that. So here's a couple of our assumptions about and based on research, of course, the differences between the Chinese and the US systems. So China, as you know, has a system with much more top-down control. The government gets a lot of say, and they have a ton of influence over their private sector, which came into play when we were trying to include the private sector in sort of a commercial bot phase. In addition, I think a common narrative about China in technology development is that they're sort of hackers. They're catching up, they're stealing the technology, and they're really trying to like climb their way to become real competitors. And that might have been true at one point, but it's not true anymore. They're transitioning from this era of hacking and catch up to an era of really building up their domestic innovation and really being competitors. And that's true now, and it will be true in the next couple of years. And so the US started with a lead in this space, but China's gaining ground. So where are the US advantages? Well, the US has a quicker moving private sector, less ability to influence its direction. But really the strength of the US that we came across was strong international partnerships, particularly in countries that are major AI players across the globe. So we had to find a way to sort of incorporate the international community into our game without having them be actual players, because the scope would just be too big. So real quick, I'll talk about the structure of the game and then hand it off to Andrew to talk about the mechanics in a bit more detail. But we have 8 rounds in the game. Each of those translates to about a year, maybe a little bit more than a year, since we're looking at a 10-year time frame. 2 players, which are the US and China military establishments, as I already talked about. In each round, there are 6 phases. And the way to win the game is really to acquire victory points. And whoever gets the most victory points at the end wins. Getting to a technology first gives you victory points. Gaining a technology gives you victory points. And gaining complex future technologies gives a large amount of victory points. So the central mechanics of our game are really an engine builder and a tech tree, and we wanted to really elucidate the input-based model that we came across in our conversation with CSET and others. Thanks very much, and on to Andrew.
Yeah, so to get technology and win the game, you need resources. And the way you get, we have 4 resources in the game. As previously mentioned, this is this input model that we saw crop up a couple places in our research. So money is just the funds available for the US and Chinese military to buy things. We've got some lovely paper money for the players to spend. Talent tokens, this is high-skilled talent, both domestically produced through universities or military partnerships, but also on the open market. We saw a lot of places that both the US and China see this as a really competitive space for acquiring that top AI talent. Infrastructure, AI requires a lot of computing power to run, to train those algorithms, train those to do machine learning, and so investment in that infrastructure. And then finally, particularly for our game, we're thinking about data centralization, as data is specific to each problem set. The ability to have large centralized tagged data sets is critical for machine learning, and in our game gives you a discount on acquiring more technologies as you're able to centralize your infrastructure and therefore train algorithms more effectively. So we're again going back to kind of these different phases. We're going to walk through them briefly and give you a sense of it, and we're happy to take more questions on in-depth ones as we go on. So taking a look at the 6 phases of the game, as mentioned, production phase. So this players get resources based on how much they've invested in their engine for each of those 3 central resources. They then have a chance to bid on talent. They compete both with the commercial sector and the other player to do so. They bid price per unit. There's then a section of influence competition. Both players get to spend influence tokens, and then additionally, if they would like to spend money, this is your BRI initiative, your Belt and Road, your tech partnership, to increase their influence on third-party nations. We'll get into the specifics of that in a second. Players then have a limited number of actions, either to invest in their domestic engine, acquire one-time capabilities like hacking, or subsidize their commercial sector. The commercial sector then moves. This is semi-randomized. You both have more control over it if you subsidize and try to get your commercial sector to explore a specific area of technology, and there's a higher chance to succeed as well. Players, after the movement, spend their acquired resources on new military capabilities they'd like. Capabilities already unlocked by the private sector are cheaper, although players can also jump ahead if they would like. So taking a look at the technology tree, some great work here by Vikram to make it all happen. This is a combination of a conceptual tree and the game board. So the technologies kind of at the bottom are more basic and more complex at the top, more victory points for the more complex technologies. They're roughly divided into kind of 4 trees that came up during our conversations with various subject matter experts. So neural networks, natural language processing, reinforcement learning. We've combined that with robotics and then computer vision. Each kind of capability up the tree relies on the capabilities below. Both the US and China each have a number of technologies they specifically would like. For example, China's put a lot into various facial recognition and tracking technologies. And so that's represented in the game that you get extra points if you're the Chinese player and you're able to acquire the high-level facial recognition technology. Looking at the next slide. So as we mentioned, Vikram was kind enough to print some great 3D commercial bot tokens as they move up the tree. On the right-hand side, you can just see some examples of the commercial bot unlocking technologies, the player then acquiring them. Again, you have a subsidized cost if your commercial sector has already unlock the technology, and it costs more if you haven't. There's also some cards, and we'll see this in a second, that allow you to benefit from your opponent's commercial bot movement. So to buy a technology someone else has done, and you also have the opportunity to hack to acquire technologies that your opponent has. So looking at those influence cards, those partner cards, one of the big feedbacks we got early on, as Vikram mentioned, we really wanted to have like a 7-9 person, all country global fight for AI. But that quickly became outside the scope of the game and a little cumbersome to implement. But the US and China, surprisingly, aren't the only countries in the world, and not the only countries that matter in the artificial intelligence space. To represent this, we have kind of 4 partner countries that we thought were relevant to both the US and China and relevant to artificial intelligence. Players compete over influence in these nations during that influence phase. If you've got the majority of influence in a nation, you get a specific benefit. The European Union helps with your commercial sector. Taiwan, with all those chips, gives you some benefit to infrastructure. India's large talent pool provides talent subsidy, and Pakistan provides extra funding. We'll take a quick look at the card art because I put way too much time trying to get them all formatted for our final presentation. So these are the 4. We're hoping to add some more. We'll talk a little bit more later on about where we might take these. We're hoping to add some more partner cards in the future, but these are the 4 for the first prototype. So as we mentioned, you can acquire short-term capabilities instead of investing kind of long-term in various things. So we try to represent these in power cards. You cost 1 action to acquire during your action phase. There's currently 7 of them, about cyber offense, cyber defense, talent, influence, and some extra one-time funding. We'll spend a little time walking through each one, but again, we're happy to take questions on how these interact at the end. Also, as Vikram mentioned, we used kind of a publicly available AI art generator for the majority of our art design in the card. I think it's called Wimbo, but if you search AI art generator, it'll probably be your 3rd top hit. It was very popular on Twitter when we were designing. So offensive hacking allows you to acquire technologies that your opponent has already acquired with some chance of failure. Cyber defense, you play a counter, increases the difficulty of doing so. Emergency funding is a one-time influx of cash. It's less effective long-term than investing in your domestic engine, but is helpful if you need to push yourself over the finish line or beat your opponent to a technology. For the next couple of cards, we've got tech partnership that interacts with our influence mechanic. So thinking about those Belt and Road initiatives, the US's Quad partnerships, all the ways that we're investing in technology partnership around the world. Talent programs, right? Recruiting high-level talent from your opponent, and then licensing and acquisition and export controls interact with the commercial bot to either take your opponent's benefits or prevent that from happening. So it's been a wonderful semester designing with these folks, going from sticky notes on some laminated paper all the way up to chunky pieces in hand and demoing it for various people around DC. Important thing to note, and this kind of has come out, is the game's really more about an economic. It's an engine builder about innovation. It's not so much about each individual AI technology. We've done our best to make predictions and use expert testimony or expert opinion about what the next 8 years looks like. But all of the AI technologies don't really bleed back into the game. The point is to acquire them. We don't delve deep into what each one of those means for the country. Over time, we've also, and we're happy to expand more on this for the time, had to modify many of our mechanics. As I'm sure many of you know, bidding mechanics can be a bit challenging to get the economics just right. And pretty early on, we had some problems with players either heavily undercutting each other or ending up getting very kind of on market level, on market price results for the talent. We've continued to struggle with how best to represent this asymmetry. So in our game, the Chinese commercial sector moves slightly different than the US, and they have more control over it. But we've always been trying to figure out how to represent that asymmetry of systems. We've added more changes to movement, added some changes to how the discount mechanics work and the subsidy mechanics. That continues to be a real interesting design challenge that we've delved into. thinking about where we might want to go in the future. We still have some balancing to do with the hacking cards, particularly, but thinking about how we want to represent those one-time mechanics. Unfortunately, right now, because the hacking mechanic allows you to take any technology, it's actually more worthwhile at the end. And this actually is counter to what experts are saying, that hacking seems to be more of a short-term strategy to catch up rather than a long-term thing. And so as China in particular really builds out its AI capacity, which it's doing, and publishing great research papers, hacking is less of a national strategy than it is at the beginning. As always, we mentioned AI is kind of everything and therefore nothing at all. Because it represents so much variety of sectors. So thinking about what we want to include in the technology tree, killed Vikram and I hearts to cut some bio areas from that. We also don't have a lot of cyber in there, which is another emerging area. And finally, looking at the influence phase, we've mentioned those kind of 4 countries we think are critical. However, we had to make some accommodations for the mechanics of the game. For example, Pakistan, while an important geostrategic area, isn't as big an AI player as the other 3 in there. We didn't want to have a situation where China started with no partners and they just watched the US sweep the national globe. And then thinking about what nations that are important that we didn't include going forward. Thank you so much for your time. We'll start to take some questions from the chat now, and thank you for listening to our presentation. All right. So first question, IT development programs can vary wildly in resource requirement. Your tech seems to assume uniform sizing. How did you consider evaluate this dynamic? Sasha, you want to jump in on this one?
Hang on, just reading in YouTube as well. Vikram or Andrew, if you want to take it.
Yeah, so you're absolutely right that the cost does increase by tier. So the bottom tiers all have the same cost, and the top tier has more cost. So we tried to put more highly complex technologies at the top. But you're right that there is, for each individual thing, a difference in how one technology might require more computing power, more talent, or might be more money intensive. Our kind of tier system was a sacrifice to playability. Players were having a hard time doing all of the math, figuring out the cost of things increasing. And so we found it better to have it all in the same tier. But you're right that is a sacrifice to playability, although the higher and more difficult research ones do require more as you go up the tree.
Yeah, for sure. I'd also say part of the challenge with that as well was trying to predict how much things would cost, because we were sort of, the more complex the technology, the higher the cost would be, was our basic assumption going through, which obviously makes some sense. But a lot of the technologies that were on the tree are technologies that don't exist now, or that do exist, but in very limited form. So trying to predict exactly how much they'd cost, how many resource inputs would go into them, was sort of an exercise in giving it our best guess, doing as much research as possible, and as Andrew mentioned, we also had to sacrifice a little to make sure that each of the technologies and each of the tiers cost the same, just for the sake of playability. But hopefully that makes sense.
And then the next question, your hacking mechanic focuses on stealing a tech versus disrupting development, a possible alternative use with variable cost. So I think you may be suggesting, for example, the hacking mechanic would involve hindering the opponent over several turns, like diminishing their engine builder or renewing resource like talent or money over several turns. I like that idea. Andrew, what do you think as the spreadsheet wizard?
Yeah, as Sasha's referencing, I spent a lot of time trying to figure out the resource curve and making sure that everything made sense. We did think about some kind of block mechanic. So, for example, hacking to prevent acquiring the next level of technology. We found that kind of 1 or 2 times read that it was very frustrating for players, although that is like representative. One of the big things we did want to further develop is how to really impede player progress, because right now, while you can hack and you can bid for talent, there isn't as many ways to degrade the opponent's capacity. So modifying hacking in that way would be one way to incorporate that kind of direct player interaction.
For sure, and that's something we consider doing. I think part of the challenge with that is because the game depends so much on the engine and every action, like spending an action to improve an engine is really powerful. Being able to prevent an opponent from doing that would also be extremely powerful, and we worried that it would throw off the balance of the game a little bit and maybe take away some of the incentive to do other things in the game. One of the ways that we wanted to maybe introduce a little bit more of that competition into the game is by including victory conditions, or more accurately, sort of victory point acquire conditions, where both the US and China have their own specific technological goals that they're working towards. So we came up with a couple of those, one for China, one for the United States, and then we had some of those goals be on the same path, which would, force the two countries to sort of compete with one another to try and be the first to each of the technologies on those paths. But certainly, one thing that we really would like to incorporate more going forward is ways for the two players to interact with one another in more direct ways.
Yeah, thanks for coming, everyone. We'll be continuing this discussion, if you do have it, in the Discord after this. We thank you so much for your time and for your great questions, and look forward to seeing you guys at the rest of the conference. Have a great one.